In example number 3, we'll be talking about average values. So in general, the mean of any probability density function f is defined to be the following. The population mean, which is this symbol mu, is equal to the integral that goes from negative infinity to infinity, x f of x dx. Now for example number 3, we want to be able to find the mean of the exponential distribution of example 2, where the piecewise function states that f of t was equal to 0 if t is less than 0, and f of t is equal to the function c e to the negative ct if t is greater than or equal to 0. Now according to the definition of a mean, we have the population mean up here, goes from negative infinity to infinity, t f of t dt, since we're replacing t to be x. So because of that, when we turn this into two integrals, the first integral that goes from negative infinity to 0 is going to be 0, so we only are concerned with the values that are greater than or equal to 0. So now we're going to go from 0 to infinity of t c e to the negative ct dt. So to evaluate this integral, we're going to use integration by parts, with u is equal to t and dv is equal to c e to the negative ct dt. The derivative of u is going to equal 1, and the antiderivative of dv is going to equal v, which is equal to negative e to the negative ct. So therefore, using this integral, we're going to take the limit as x approaches infinity, as 0 goes to x of that function, which is now going to equal the limit as x approaches infinity of uv, which is negative te to negative ct that goes from 0 to x. It's going to be minus a negative, so it's going to be plus the integral that goes from 0 to x, e to the negative ct dt. So the next thing we want to do is we plug in the value of x, we get negative x e to negative cx, and then the limit of the first term is 0 by L'Hopital's rule, so it's going to be plus 1 over c minus e to the negative cx over c. And as the limit as x approaches infinity, this is going to become 0, this is going to become 0, so the limit is going to equal 1 over c. And therefore, the mean, or the population mean, is equal to 1 over c, so we can rewrite the probability density function as the following. F of t is going to equal 0 if t is less than 0, and f of t is equal to the population mean to the negative 1 power, meaning that this is c to the negative 1. So we're saying here that mu is equal to 1 over c, which is c to the negative 1. And so therefore, this is going to equal mu to the negative 1, e to the negative t over u if t is greater than or equal to 0.